Welcome students to lesson 11 of the natural hazards topic. In this lesson I introduced the idea of a tropical storm. These are some of the most powerful and devastating natural hazards found around the world. Many thousands of people are affected by them each year. In this lesson you're going to understand what a tropical storm is, how they form, and where they are found. Let's go. Please write the date, title and learning objective. Have a pen and paper ready to learn. Time to review prior learning. Please write 1 to 14, answer the questions from memory, and then mark your answers. Game time. 1. Low air pressure on the ground means air is rising. 2. When air rises, it cools down. 3. Clouds form when there is low pressure. 4. Clouds form because when air rises, it cools and condenses. 5. High air pressure gives clear skies. 6. At the equator, there is low air pressure. 7. At the equator, the air is rising to form clouds. 8. At the equator, the sunlight hits the earth directly. 9. At the poles, there is high air pressure because the air is cold, dense and sinking. 10. The layer of air around the earth is the atmosphere. 11. Air pressure means the amount of air molecules in an area. 12. Air pressure is lower at higher altitudes. Altitude, remember, means how high up you are above the sea. 13. Evaporation means when water warms up and turns to water vapor, a gas. Evaporation, I should say, means when any liquid warms up and turns into a gas. 14. High air pressure on the ground means air is sinking. Give yourselves a mark out of 14. If you got 12 or above, fantastic, you've really understood these difficult ideas. Any questions you got wrong, come back to this and test yourselves on them repeatedly until you've memorized them. To introduce the idea of tropical storms, I'm going to show you a photo and some questions. Use the understanding you already have to try and answer the questions, and then we will discuss them. Let's recap quickly. This, if you remember, is a diagram of global atmospheric circulation, which means how the air in the atmosphere moves around the world. We saw last lesson how at the equator air is rising because it's the warmest here as a result of the sun hitting the earth directly. It rises because warm air is less dense than cooler air. We also learned how when air rises it cools down and condenses to form clouds and therefore rain. But as it reaches a certain point, the top of the troposphere, which is the lowest layer of the atmosphere, it spreads out as cool air, becomes denser, and sinks at 30 degrees latitude north and south of the equator. This sinking air then spreads out both back towards the equator and towards 60 degrees north. This circular movement of air, here and here, is called the Hadley cell. It's a convection cell, where warm air rises and cold air sinks. At 30 degrees north and south of the equator, you have clear skies very often, so you have hot deserts here. This is because there is high air pressure, lots of air near the ground, sinking air, meaning there are no clouds and therefore no rain. So, for example, at the equator we have rainforests because of heavy rainfall regularly due to the low air pressure here. At 30 degrees north and south we have hot deserts like the Sahara here. In the UK, just below 60 degrees north, we often have low air pressure, and that's why we have regular rainfall here. Rising air. And at the north and south pole, there's high air pressure, sinking air towards the ground, which means that there is very little snowfall and rainfall, and consequently it's dry here. Antarctica is the world's largest desert. Okay, let's introduce tropical storms. Tropical storms are possible because of global atmospheric circulation. The rising and sinking of air is what allows a tropical storm to form. Let's go. Here's a picture. Very impressive one taken just last year. So question 1, what type of storm is this? You could have said it's a tropical storm or a hurricane you may be more familiar with. 2. Where in the world is it? Well, you may have recognized this shape here. This area here is Florida. This is a state in the United States of America. And consequently, you can say that this is the Atlantic Ocean and this is the Gulf of Mexico here. And further south, you have the Caribbean. 3. How did the ocean create the clouds that we see here? You could have said, if you recalled your prior knowledge, that the ocean created the clouds through evaporation of water in the ocean. That water vapor that rose due to being less dense than surrounding air condensed into water when it reached higher altitude due to the cooler temperatures, therefore forming clouds. 4. Why do warmer oceans mean bigger storms? A storm this size only occurs in this area and near these latitudes, as we will discover later on in this lesson. And that's because warmer oceans mean more evaporation, and you'll find out why that's so important now. So this lesson, you're going to master 3 key questions. What is a tropical storm? How do they form? And where are they found? Every time I show you a subtitle, I'd like you to write it on your paper or in your computer and underline it. And I'd like you to write very brief notes based on what I say. And you may add diagrams from the internet if you want, but you don't have to. But make sure you write down key notes and key points of what I say. You might want to do it in a flow diagram form, which is sentences with arrows connecting them to show how one thing leads to another. Let's go. So what is a tropical storm? Well, here is a typical tropical storm. This is Hurricane Irma over Jamaica in the Gulf of Mexico and the Caribbean and West Atlantic Ocean, and it's soon going to hit the United States of America. A hurricane is a type of tropical storm. So what are the 2 core features of a hurricane? Well, look at this picture clearly. You'll notice it has clouds surrounding a clear area in the middle, and it's got these clouds in an interesting revolving direction like this. It's not just a mass of clouds. It looks almost like when you open the plug hole in your sink and all the water goes down. A tropical storm is an area of intense low air pressure, so rapidly rising air, forming enormous clouds. It's also a rotating storm. It spins. As a result, there is tremendous wind speed within the tropical storm. For a tropical storm to be a tropical storm, it must have a minimum average wind speed within the storm of 74 miles per hour or above. That is extremely powerful, enough to knock someone down. Now, a tropical storm, as well as being an area of extreme low air pressure and a spinning mass of clouds like this, has to be found in a certain part of the world. Tropical storms are only called tropical storms when they form between the Tropic of Cancer at 23.5 degrees north of the equator and the Tropic of Capricorn at 23.5 degrees latitude south of the equator. Any storm forming outside of these latitudes is not a tropical storm. These are the tropics. You may be familiar with tropical storms from their different names based on where they are located in the world. If a tropical storm forms in different oceans around the world within these latitudes, it has different names. In the Atlantic Ocean here, tropical storms are called hurricanes, probably the most famous type of tropical storm because they hit the richest country in the world, the United States of America, here. Hurricane Katrina was the most expensive natural hazard in the world, and it hit America in 2005. When tropical storms hit the western Pacific Ocean here and parts of central Pacific Ocean, they are called typhoons, Typhoons. So, for example, Typhoon Hagibis, which hit Japan in 2019 and affected the Rugby World Cup, is an example of a typhoon. And finally, If a tropical storm hits the Indian Ocean, located here, affecting countries such as Madagascar, South Africa, all of East Africa, India, Sri Lanka, and parts of Australia and Indonesia, it is called a cyclone. Cyclone. All of these different words, hurricane, typhoon, and cyclone, they are all different names for tropical storms, but they are all exactly the same thing. That's an important idea. A typhoon, a hurricane, and a cyclone are the same thing. They are all types of tropical storms, and the only difference is which ocean they are found in. So now the key question. How does a tropical storm form? Interestingly, scientists today still do not know the exact way that every tropical storm forms, step by step. But we have some main steps that help us to understand how tropical storms form. Let me show you. So please write the subtitle and underline it. You may wish to draw a basic version of the diagrams that I show you. So a tropical storm all starts with rising water vapor between the tropical latitudes, the Tropic of Cancer and the Tropic of Capricorn. Most tropical storms form between 5 degrees and 15 degrees north and south of the equator. This is mainly because the water temperature here, due to the direct angle of the sun, is warmest here. It has to be above 27 degrees Celsius, down to 100 meters deep for a tropical storm to form. So what happens? Between these latitudes, the warm ocean water evaporates very rapidly, turning into water vapor. This warm water vapor then rises up to higher altitudes. When the warm water vapor rises up to these higher latitudes, it cools down and condenses to form large clouds. So that's the first step. Warm water leading to rising water vapor. But it's more than that that's needed. Usually, the wind speeds at higher altitude are much faster than the wind speeds at lower altitude. This means that if you have a tall column of cloud like this from the sea level all the way up, that cloud can be torn apart, the top ripped off by the much faster wind speeds in the higher altitudes than the lower altitudes. This prevents a tropical storm forming. This difference in wind speed between high altitude and low altitude is called wind shear, S-H-E-A-R. And much like the shears that you might use to cut a hedge, it shears off the top of a cloud. So the second ingredient needed for a tropical storm to form is low wind shear. The difference between high altitude wind and low altitude wind must be very small. That prevents the clouds that have formed due to rising water vapor from being destroyed. Now, if the clouds are allowed to form, then they grow and grow as more water vapor rises. And eventually, the clouds start to spin. This happens between the tropics of Cancer and Capricorn. This happens between the tropics of Cancer and Capricorn because of the rotation of the Earth. The Earth spins around its axis, which is like an invisible pole that goes through the North Pole all the way to the South Pole. Now, because the Earth is a sphere, and it's widest at the equator, that means that areas closer to the equator are actually spinning faster than areas further from the equator. Meaning that, since air on Earth travels from the tropics of Cancer and Capricorn towards the equator, so directly south toward the equator and directly north, they actually change direction due to the faster movement of the Earth nearer to the equator. So that air traveling south from the Tropic of Cancer to the equator is deflected to the right. It falls behind the equator. Whereas air traveling north towards the equator from the Tropic of Capricorn is deflected to the left. Consequently, in the northern hemisphere, so the half of the Earth north of the equator, the winds that meet at a tropical storm start to spin the storm anti-clockwise because the winds are deflected to the right. By contrast, winds in the southern hemisphere, so south of the equator, since they are deflected to the left, cause the tropical storm to spin clockwise. So how do the winds and why do the winds come in towards the storm anyway? Well, as you notice here, the rising air leaves an area of low air pressure beneath the storm clouds that are forming here. That low air pressure has to be filled in because air always moves from areas of higher air pressure to areas of lower air pressure. And the bigger the difference between one place and another place in air pressure, the faster the air moves. And so the rising air of a tropical storm causes air to move in from around it. And that creates wind. That also has another effect. That air moving in allows the tropical storm to spin since the air is coming in at an angle. Over time, this tropical storm's clouds and winds may get faster and faster. Why? Well, it all lies in the clouds. When the warm air rises as it's spinning very rapidly towards the clouds and condenses to form clouds, it releases heat. Condensation, where a gas turns into a liquid, releases heat. Now that heat that's been released from condensation into clouds warms up the surrounding air and consequently warms up the water further beneath it. And that warmer air and water becomes less dense and consequently rises faster. And since it rises faster and condenses more into ever larger clouds, you get yet more heat released, and so yet more rising air and water. And this process repeats and repeats until the clouds get bigger and the wind gets faster and the rotation speeds up. And finally, more and more air is sucked in, so that eventually you may get this. This is when these clouds have become a tropical storm. You have connected rain clouds like this that rotate either anti-clockwise in the northern hemisphere or clockwise in the southern hemisphere around a central calm area called the eye. When these winds that are spinning round and round reach 74 miles an hour, then you have a tropical storm. Beneath the tropical storm, you have extremely low air pressure as the air is rising rapidly. Air is being sucked in from all around. Clouds are becoming huge as a result of the rising water vapor condensing to form them. And this makes a tropical storm. The effect of the Earth's rotation that causes tropical storms to spin like this is called the Coriolis effect. Coriolis. It's named after the man who discovered that spheres, when they rotate, actually rotate faster near the equator, near the middle point, and therefore cause winds that move towards the equator to change direction, or away from the equator to change direction. We will learn more about the Coriolis effect next lesson, but just know that it happens because the Earth rotates, and it is responsible for making tropical storms spin like this. Key idea here. Tropical storms become more powerful over time because they are fueled by the warm water beneath them. The clouds form because of rising water vapor. That water vapor comes from a warm ocean above 27 degrees. The wind forms because of the rising air creating low air pressure beneath it. Without the water vapor and without the warm oceans, a tropical storm cannot form. So that if a tropical storm travels over land, it will eventually die out and be destroyed. The clouds will disappear, the wind will stop, because there's no more rising water vapor. So if that is how tropical storms form, how does that help us understand where tropical storms are found? Here is a map that shows the position of most of the world's tropical storms and where they have travelled over the last 50 years. As you can see, in the Atlantic Ocean, you have the hurricanes. In the Indian Ocean, you have the cyclones. And in the Pacific Ocean, you have the typhoons. In some cases, hurricanes can form in the eastern Pacific Ocean here, off the east coast of the Pacific Ocean and the west coast of America. And in some cases, cyclones can form off the east coast of Australia like this. But typically, cyclones, Indian Ocean, typhoons, Pacific Ocean, hurricanes, Atlantic Ocean. You should see that almost all of the storms form and only travel within the tropics of Cancer here and the Tropic of Capricorn here. This is because the water within these latitudes is warm enough to sustain them, to keep their winds and their clouds going. Once a tropical storm reaches these higher latitudes, the water gets too cold, and so there's too little evaporation of water, and so the clouds stop forming and the winds slow down. You should also see that tropical storms do not form along the equator here. This is because the Coriolis effect, caused by the difference in speed of the rotation of the Earth as you go further from the equator, does not actually happen along the equator, so that storms forming on the equator cannot spin, they cannot rotate. Consequently, you don't have tropical storms forming along the equator. The world's most powerful tropical storms tend to be in the northern Pacific Ocean here, because the water is warmest there. But they are generally most frequent in the western Atlantic Ocean as hurricanes here, and they are certainly the most monitored and most well known here. So these are the key ideas of tropical storms and where they are found. I will put this video as a link beneath the video lesson so that you can watch it in your own time and develop your understanding further of it. Time to assess learning. Answer the questions using your understanding and then mark your answers. 1. What is the minimum wind speed needed for a tropical storm to be called that? 74 miles per hour. 2. Between what latitudes do tropical storms form? Between 5 and 15 degrees north and south of the equator. 3. What is the minimum water temperature needed? About 27 degrees. 4. Evaporation happens when water is warmed up. 5. Condensation releases heat. 6. Tropical storms are called cyclones in the Indian Ocean. 7. Hurricane Katrina happened in the Atlantic Ocean. 8. Tropical storms happen in the late summer and autumn because the ocean takes a long time to warm up to 27 degrees. Give yourselves a mark out of 8. If you got 7 or more, excellent. If not, please go back and watch the explanations again. Time to embed the learning. Read the paragraph and add the correct words in the gaps, and make sure you write out the whole paragraph in this case, adding each of the correct words as you go, and then mark your answers. So let's review. When air rises, it creates an area of low air pressure beneath the rising air, which pulls in air from around. Remember, that's because air always moves from where there's high air pressure to low air pressure. Due to the Coriolis effect, this air being pulled in is deflected to the right in the northern hemisphere and to the left in the southern hemisphere. This causes a tropical storm to spin or rotate. Tropical storms form between 5 to 15 degrees north and south of the equator. The water must be over 27 degrees C, and the wind shear must be gentle to avoid damaging the clouds. Remember, wind shear is the difference between wind speed at high altitude and low altitude. As water vapor condenses into water in clouds, it releases heat, which makes the air less dense, causing it to rise more, which allows more water vapor to evaporate and rise. The faster air and water vapor rise, the lower the air pressure becomes, and the faster the winds become as air rushes in from around. The Coriolis effect makes the storm spin, which makes air rise faster and winds stronger. Tropical storms never form on the equator because the Coriolis effect is weakest here, so storms cannot spin and grow. Give yourselves a mark out of 15. Make sure you've written out the entire paragraph with the words added in correctly. If you got 13 or more, awesome. In a week's time, come back and test yourselves on these 1 to 15s, just writing the keyword answers. From the lesson, write 2 questions based on anything you learned, ideally on any 2 facts or steps. Answer those questions from memory, and then in a week's time, test yourself on those questions to see if you've memorized them. Next lesson, we're going to be exploring further about tropical storms, and we're going to be understanding their structure. And from then, we're going to be exploring a case study of a devastating tropical storm. Join me then.